All right, so on 6.6, we are doing function operations and composition of functions. So that's the title of this. You might have seen this on the ACT where we had two different functions with two names, and it tells us what to do with those two functions. So think about our problem on number 1. We have a g function, its name is g. We have the f function, its name is f. The little parentheses next to it are just telling us what variable our function is using. So I would say g of t or f of t, just like we normally say f of x, right? F with the little x. The x is just telling us, or in this case the t, that that's the variable that gets used in our problem. It doesn't need to multiply by anything. That's just specifying my function's name is g, the variable I use is t, okay? So they're going to give us two functions, and then they're going to tell us what they want us to do. So if it says f or g plus f of t, what operation do you think we're going to do with g and f? You can just show me with your hands. If it says g plus f, we're going to add them together. So all this is telling me to do is just telling me to add g of t and f of t. So I just take these two functions that they give me and put a plus sign between them and combine like terms. So g plus f of t equals g of t first, because they told me g first, 3t minus 1, plus the f function. My f is 4t. So if there's a plus, they're just telling you add your functions together. We'll combine like terms, and then we'll be done. All right, I have a 3t and a 4t, and that makes how many t's? 7. 7d, not really, 7t, minus 1 would be our answer. So g plus f of t just says add together the g function and the f function and combine like terms. Thumbs up if you're okay with that. Plus sign means we add them together. Okay. All right, on number 2, we have a minus sign. So what do you think we're going to do on number 2? We're going to subtract them. But what you have to remember when you're subtracting is we're going to have to put parentheses around whatever comes after the minus sign, because we need to distribute our negative in a minute. So we do our h first. So h minus g of x. The h is x plus 5, right? That was my h function, is x plus 5. Minus, I'm going to write the g function, is x squared plus 4. I put the parentheses because the minus is going to have to be distributed. I can't just put a minus in between the two of them because it affects the x squared and also the 4. That's a mistake that people make all the time. So this is a big mistake if we're not putting the parentheses. So those are necessary. I'll distribute the negative. So x plus 5 minus x squared minus 4. Y'all good with that so far? Give me a nod if you are. Good. All right. And then we write it in standard form where we go from highest power to lowest power, combining like terms in the process. So my highest term is negative x squared plus x. Then 5 and negative 4 make a positive 1. If I write them out with a minus in between and parentheses around the second function, distribute, then combine like terms. Nothing from these two is new. It's just that you just hadn't seen this notation before. So that notation has nothing to do with multiplying by x. The x or whatever's in the parentheses just says that's the variable that's being used in this problem. Okay. Anybody still need number 2 before I scroll? Got it. Okay.
Yeah.
All right. Oh, you do?
I got it.
Okay. All right, number 3 and 4. On 3, we have this little teeny tiny dot. What's that little teeny tiny dot mean? What operation is that? Multiply, so we're going to do F times G. And on number 4, we've got H over G, so then that one we will divide. So let's start with number 3. This means to multiply with the little dot. And in this case, we have to put parentheses around both, and we get to distribute. You know, the distributing you guys love to hate and hate to love. Just kidding, you just hate it. So when you're multiplying, you need parentheses around both, and we're going to distribute all the problems. Sometimes you might just have one term instead of two, in which case you just distribute that. So we're going to multiply these together. Again, I don't do anything with this x at the end. That just means that the equation has an x in it. I'm going to start with my 3x times x to the third. And that's going to be 3x to the fourth. Everybody okay with that? All right. And 3x times 1 is 3x. And 5 times x to the third is 5x to the third. And 5 times 1 is 5. Is this problem written in standard form, where we go from highest power to lowest power? No, I need to rearrange it, and then I'll be done. So 3x to the fourth plus 5x cubed plus 3x plus 5. So I just had to swap these two to be in standard form. And when you have multiplying, put parentheses around your problems, distribute. Sometimes you might have to combine like terms. Historically in your math career, has dividing seemed like it was always the most difficult thing of all the things? Like you're like, oh, all these other things are easier, and then dividing, and then the fractions, and then, well, guess what? On these problems, it's the easiest, okay? Because we don't know how to simplify when we have x's yet with fractions and plus signs, so we're not going to do the simplifying. We're just going to write it, one function on top, one on the bottom, and leave it there, okay? Yeah, Wi-Fi is being horrible today. If you miss something, this is being recorded and it will be posted so you can watch it. So number 4, we've got h over g of x. Which function should be going on the top? Y'all can make the letter or mouth it. The h, because that's on the top. So I'm going to write what h is. Negative 2x plus 1. Then the g function's going on the bottom, and that was 2x plus 2. How are we feeling about these 4 problems and problems like this? So do whatever the operation tells you to do. You're either going to add them together, subtract them, multiply, or divide. So those are our function operations. The next thing we're going to do is called composition of functions. We're composing them together. We're going to start with one function, evaluate it, and then use that number to evaluate our second function.
I have a question.
Uh-huh.
So for number 4, is that just how it is?
Yep. That one actually doesn't even cancel or anything. There's no way to simplify it because of the plus signs, and we'll get to that. I think we do that in May. Well, I think that's how I have it planned out, to when we'll start to be able to do some simplifying if we can. We can't just cancel these 2's because of the pluses. It's because of those. So we just keep it like that on number 4. All right, on the rest of them, we are going to do compositions of functions. So if you have some space on top of these problems, that's good. Otherwise, just write it to the side. I just want you to know how we read or how we say these things. So there are two different ways that we can write the same thing. I think it just depends on personal preference. If you prefer the first option or the second option, they mean the exact same thing. You evaluate them the same way, you read them aloud the same way, their just notation is written differently. So the first one, we have an f and then it's of g of x. So instead of just one function and variable, we're going to have two. But we have the g of x plugged into the f function. So that's f of g of x. That's how we say that, f of g of x. Another way that you might see this is written in this format. This is not a times sign. It's a little o. It's not on the same level as the f and the g. It's not written like fog. It's written like f, and then it's an o in the center, and then a g here. So just how, you know, it's kind of hard sometimes for me to see it. Oh, I have one that's typed right there, so you can see it in this problem. It's a little o like that. So that's going to tell you to do a composition. It's not going to be multiplying. All right, so f of g of x. So we're going to work our way from the inside out. We're going to evaluate what we have on the inside first, get that answer, and then we're going to plug that in. So they want us to figure out, like particularly on number 5, they want us to do h of -2 first. So we're going to forget the g even exists. We're going to evaluate h of -2, get that answer, and then we'll talk about the g. Okay, so we go from the inside out. Doesn't that follow your order of operations that you do your parentheses, the stuff on the inside, and then you build your way to the outside? So we're going to work on what we have on the inside first. So that was h of -2, right? That's my inside. And remember, if you're evaluating a function like h of -2, to get your answer, you plug -2 into whatever variable you have, right? We remember that? You're plugging into that variable. So h of -2 is -2 times -2 minus 1. I just plugged the -2 in where I saw the variable. Everybody got it? You're on the same page. I just plugged -2 in where I saw the variable, and I'm dealing with the inside function right now. That's my inside one. Okay, then we're going to see what this is. Anybody think they got it? Hold your fingers up. If you think you know it, what is the answer for this part? And you do it in your head. -2 times -2 is 4. 4 minus 1 is 3. Okay. So h of -2 is 3. So I've done my inside part. H of -2 is 3. So I'm going to replace where I see h of -2. I'm going to replace that with a 3. So now I'm going to find g of 3. Since h of -2 was 3, I'm just going to substitute that in there. So look at that. See if you get what I just did. I evaluated the -2, did that. That was 3. So now I'm doing g of 3. Okay. So I'm going to plug 3 in to my g equation. So that is 3 squared minus 2. Go ahead and hold up your fingers. What's your answer for this one? 3 squared minus 2 is 7. Yep. Because 3 squared is 9, minus 2 is 7. So our final answer of g of h of -2 is equal to 7. It's basically just doing 2 evaluating problems. So you evaluate the first thing on the inside. Whatever that answer is, you use that and plug it in your second equation. So let's try another one. Make sure we're good. Our inside is f of 0, so that's what we'll evaluate first. So here's my f. I'm going to do 0 cubed plus 3. Plug that into my f function. What is 0 cubed plus 3? 3, good. 0 to any power is 0, plus 3 is 3. Okay, and so now, which equation do we plug our 3 in, the G or the F? Y'all can now, do I plug it in the G or the F? I plug it into the G function, right? Because now I have my 3, that 3 is going into the G function. So 3. It's a lot of 3's in this problem. Three times 3 is 9, plus 3 is 12. So G of F of 0 is going to equal 12. Okay, so far so good? Thumbs up, thumbs down?
I have a question.
Yes, ma'am.
So when we do the CUDA works, is that going to be the answer, or is it just going to be like 12?
The answer would just be 12.
Okay.
Yeah, I'm pretty sure. I haven't tried to go through that one, but it would just probably say 12 or 7. But I just wrote down this part again. That's all I did. What they asked you to find. All right, when you get to these next ones, I always rewrite these because I like to have like the parentheses inside the other parentheses problems instead of writing it like this. It helps me out. So what I do, I'll actually let y'all write that down. I don't think y'all got it before. So go ahead and write 7 and 8 down real quick, both of those problems with some space, and then I will show you how I rewrite those with parentheses, and we'll work those out. All right, on number 7, this is read G of F of 6. Remember, we said it's just another way to write it, a different notation. I always rewrite those just to help me know what needs to go on the inside, what needs to go on the outside for my things. It's G of F of 6 is the same as G of F of 6, right? Those two are the same. So I either rewrite it or I just put an extra thing of parentheses right there, just so I know I'm doing F of 6 first, then whatever I get, I'm going to use that in the G function. So we're still doing the inside, but the inside is the F of 6, so just don't get that confused on there. So we'll start with F of 6. We're going to plug 6 in. We have 2 variables in this case. The 6 goes into both of them. So we'll have 6 squared minus 6, because the 6 went into both of our variables in our F equation, which is 36 minus 6, and that is 30. Good. All right, so now y'all tell me, where does the 30 need to go? 30 needs to go in the G. Okay. So y'all plug 30 in the G real quick, see what you get. And we'll make sure we all got the same thing. Plug 30 in your G. We're going to do G of 30. Ooh, I see some people holding those hands up and show me. Give me a thumbs up if you think you got it. Okay, so that is 2 times 30 plus 2, 60 plus 2, and that is 62. That's what I saw for most of you guys was 62. So our answer, G of F of 6, oops, I wrote a G. Sometimes I write a G instead of a 6. Of 6 is equal to 62. Do you guys think we need to do one last one of these, or are you okay on the plugging the numbers in? Y'all feeling all right plugging your numbers in? Just remember on 8, it would go H of G of 0. So the G of 0 is first, and then plug that number into that H. Do you want me to write down 8 just so you have it? You can write it down if you want to. Okay. So we're doing G of 0 first. So 0 is going into my G equation. And that will be 0 plus 3. And then the 3 goes into my H equation.
Excuse me, Miss Roselle.
Uh-huh.
My Wi-Fi had kicked me.
Okay. Oh, and again. So we got negative 22 on number 8 when we did H of G of 0. So G of 0 came first. You got a 3. Plug the 3 in. And once you get to this point, you can just type that in your calculator if you want. I just don't have one out here to type it into, so I did it by hand. Make sure you put parentheses around numbers that you're squaring, and just in case it gets messed up with negatives and stuff. All right, we are almost done. We're going to have tons of time to work today. These don't take that long to do they? I don't think so. You only have 20 problems for homework, too. All right, go ahead and write 9 and 10 down, and then we'll work those. But go ahead and get the problems written down if you haven't already. All right, here we go with 9 and 10. What is missing on 9 and 10 that we had on all the other problems that we just did?
A number for one of the variables to go into.
Yeah, a number that we're going to plug in. So they don't give us a specific number. So instead what they're telling us to do is they're telling us they want us to plug the entire g of x function, the entire thing, all of it, variables and all, into the f function. So we're going to write it like this, okay? We know g of x is x squared plus 1. Everybody agree g of x is x squared plus 1? So I'm going to replace my g of x with x squared plus 1. That's what I'm going to find. F of x squared plus 1. What you've done so far in school is doing like f of 2 or f of 5, where you're plugging that number into that specific variable. In this case, instead of just plugging in one number, we're going to plug in this entire expression into our f equation. So anywhere we see an x in our f equation, I'm going to replace it with this x squared plus 1. Okay? So everything else I'm going to write exactly the same, but where I see x, instead of x, I'm going to put in parentheses x squared plus 1. So that gets substituted there. Are we okay? What we're doing? All right. So my f is 3 times x plus 2. So instead of writing x, I'm going to write all of this stuff because that's the stuff that we always substitute in for x. So 3, I'm going to change the x. Instead of that, I'm writing x squared plus 1. And then I leave my plus 2. So it looks exactly the same, except the x has been replaced with x squared plus 1. Y'all follow? I just changed that. Okay? And then now, do you think I'm going to let you leave all these parentheses in a problem? Nope. If you do, you haven't met me yet. Actually, y'all, most of y'all haven't met me, actually, in the real person. So we'll distribute. And if we have like terms, we'll simplify those. Which do we have like terms? Yeah. So since g of x was x squared plus 1, I put that in there, okay, because I know that's what that is. And now I'll evaluate f of x squared plus 1. Are we ready to try the second one? Almost. Okay. So h of a is in the middle. That's the inside. So I'm going to put my entire h of a, which is a squared minus 4, in there. So I'm going to do g of a squared minus 4. That's going in. I'm going to plug that in here. Okay. So if I'm asked to do g of something, that means to replace any of my variables in my original equation with the a squared minus 4. So go ahead and on your paper write out how it needs to be written. With instead of an a, you're going to do a squared minus 4 in parentheses. So go ahead and write this next step. Then I'll see if, and then y'all can see if you got it correct for your next step of your problem. You can use this as a reference if you need to. All right, how's it going? I think we got it. Okay, let's check. -4. Well, there's the a. I don't want a anymore. I want to write all this stuff in the parentheses. A squared minus 4. Then my minus 1. There's no variable there, so I just have to keep the minus 1. Okay, and then now we distribute. I don't think you distribute in very many of your homework problems, but I wanted to make sure that you were familiar with that in case you do have to. So -4a squared What kind of 16 is this going to be? A plus 16? Then minus 1.